What if everything we thought we knew about the center of our galaxy was completely wrong? For decades, scientists have been convinced that Sagittarius A star, the massive object at the heart of the Milky Way, is a supermassive black hole. But groundbreaking new research suggests we might be staring at something far more exotic and mind-bending than we ever imagined. Sagittarius A star, or SGR A star, as astronomers call it, sits 26,000 light-years away from Earth, harboring the mass of 4 million suns compressed into a region smaller than Mercury's orbit. For years, this cosmic heavyweight has been the poster child for supermassive black holes, with stars whipping around it at incredible speeds, some reaching up to 5,000 kilometers per second. The evidence seemed ironclad. We observed stars dancing in tight elliptical orbits, exactly as Einstein's general relativity predicted they would around a black hole. The Event Horizon Telescope even captured what appeared to be the shadow of this cosmic monster, showing the telltale ring of superheated matter spiraling into oblivion. Nobel Prizes were awarded for this discovery, cementing Escher A star's status as a black hole in scientific history. But here's where things get interesting. A growing number of astrophysicists are questioning this conclusion, and their arguments are compelling. The problem isn't with what we can see, but with what we can't see, and more importantly, what we're not seeing that we should be seeing. Black holes are messy eaters. When matter falls into them, it should create spectacular fireworks, jets of high-energy particles shooting out at near light speed, and intense gamma-ray emissions. Yet Escher A star is surprisingly quiet. It's consuming matter at a rate thousands of times lower than theoretical models predict for a black hole of its size. It's like watching a ravenous beast that's somehow on a permanent diet. Then there's the curious case of the missing tidal disruption events. When stars get too close to black holes, they should be ripped apart in dramatic fashion, creating bright flares visible across the electromagnetic spectrum. We've detected these events around other galactic centers, but SGR A star has been remarkably well behaved, showing far fewer of these stellar snack sessions than expected. Dr. Maria Rodriguez from the Institute for Advanced Astrophysics puts it bluntly. If SGR A star is a black hole, it's the most polite and restrained black hole we've ever encountered. The lack of expected high-energy emissions is becoming harder to explain away. So what could this mysterious object be instead? The alternatives are mind-boggling. Some researchers propose we're looking at a gravastars, theoretical objects where space-time itself becomes so curved that it creates a bubble of dark energy. Unlike black holes, gravitars have no event horizon and no singularity, just an incredibly dense shell of exotic matter. Another possibility is even more exotic, a naked singularity. These hypothetical objects would have all the gravitational pull of a black hole, but without the event horizon that normally hides the singularity from view. The implications would be staggering, potentially allowing us to observe physics beyond our current understanding. Perhaps most intriguingly, some scientists suggest we might be witnessing a primordial black hole in the process of evaporating through Hawking radiation, or even a cluster of incredibly dense objects that collectively mimic a single supermassive entity. The evidence supporting these alternative theories is growing stronger. New observations using advanced gravitational wave detectors are revealing unexpected patterns in space-time distortions around SGR A star. The way light bends around this object doesn't perfectly match black hole predictions, showing subtle deviations that could indicate something fundamentally different. Recent computer simulations have also demonstrated that exotic objects like gravitars could produce gravitational effects nearly identical to black holes, at least from our distant vantage point. The key differences would only become apparent through extremely precise measurements of orbital dynamics and electromagnetic emissions. If you're fascinated by these cosmic mysteries and want to dive deeper into the cutting-edge science reshaping our understanding of the universe, consider checking out Masterclass. Their astrophysics courses, taught by renowned scientists like Neil deGrasse Tyson, offer incredible insights into black holes, space-time, and the fundamental forces governing our cosmos. You'll gain access to the same concepts that researchers use to unlock these galactic puzzles, all explained in an engaging, accessible format that brings the wonders of space science right to your screen. The implications of discovering that SGR A star isn't a black hole would revolutionize astrophysics. It would mean our understanding of galaxy formation, dark matter distribution, and the evolution of cosmic structures needs fundamental revision. Every astronomy textbook would need rewriting. This mystery represents the beautiful uncertainty at the heart of scientific discovery. Just when we think we've solved the puzzle of our galaxy's center, new observations force us to question everything we thought we knew. Whether SGR A star is a black hole, gravitar, or something even more exotic, one thing is certain: the center of our galaxy still holds secrets that will challenge our understanding of the universe for years to come. What do you think is lurking at the heart of the Milky Way? Share your theories in the comments below, and don't forget to subscribe for more mind-bending space discoveries that challenge everything we thought.